Okay, so yesterday we were looking at this situation, and our main job yesterday was, if I give you a situation where there was three forces that is acting on a single object, but the forces are in three different directions. Dia bukan atas bawah kiri kanan. Kalau atas bawah kiri kanan senang tau. But if the forces are like saying it somewhere or like that kan, so we learned that we can find the value of each force. Okay, nilai bagi setiap daya kita boleh cari dengan melukis the triangle of forces. And the rule for the triangle of forces is that they must form one line. Okay, they must go in either one direction. It's not like the resultant force punya triangle. Okay, so I hope that yesterday you can differentiate between the triangle of forces when the forces are in equilibrium, and when the triangle of forces when you need to calculate the resultant force. Okay, dia punya peraturan adalah berlainan. And then of course we looked at the concept of forces in equilibrium. Okay, keseimbangan daya. When the forces are in equilibrium, okay, there are two possible explanations. Okay, and saya banyak kali sudah saya sebut ini, saya harap kamu tidak akan lupa lah. Number one, the object is stationary. Okay, dia tidak bergerak. Number two, the object is moving, but it is moving with a uniform velocity. Okay, no acceleration. The forces are still equal, okay, still in equilibrium, cuma dia boleh bergerak. Remember, whenever there is a resultant force, there is always going to be acceleration. Okay, but when there is no resultant force, there is no acceleration. Tetapi tak semestinya objek itu berhenti. Okay, it can be moving with a uniform velocity. Okay, so be very clear on that. Okay, jangan confuse between uniform velocity and acceleration. So our job today now is to calculate. Okay, of course, whenever this whole chapter is about calculate lah. So let's take a look at this example. We saw this example yesterday. Okay, so there's this tension of 8 Newton. Okay, can you see the arrow that I'm pointing? Sorry. Can you see the arrow? The weird arrow that I'm looking at. Can? Wow. Can see the arrow?
Yes.
Okay, so there's this tension over here, which is 8 newtons. Okay, it's going in this certain direction at 60 degrees lah. And then there's this P to the right, and then there's W to the down. Okay, so then of course dia punya soalan, sorry it's in Malay, this is actually from the textbook, bahkan textbook ada soalan ni kan. So find the magnitude of the tension of the string, P, and the weight of the lamp, okay, which is W. So whenever you see a question like this, the first thing you need to ask is it in equilibrium? Is it moving? Is it moving with acceleration or no acceleration? And memandangkan soalan cakap, ini adalah sebuah sebuah lampu yang digantung, means it's obviously not moving lah. Okay, yeah, it's obviously not moving, so it's in equilibrium. So if it is in equilibrium, you can draw the triangle of forces. Okay, can somebody tell me what does the red force here represent, what does the blue force here represent, and what does the yellow force represent? Sorry, somebody, anybody. Red force is what letter? Huruf apa? Okay. Red force is T. The blue force?
Weight.
Okay, weight. And the yellow force?
P.
Okay, very good. Okay, so can you tell me, okay, so this 60-degree angle, where do I put this 60-degree angle? Is it with the blue and the red, or with the red and the yellow? 60 degrees.
Red and yellow.
Okay, with the red and the yellow. So this W, this P, this is T equals to 8, and we can use red and yellow. So, can you suggest to me how we can count the W and the T? Actually, ada lebih daripada satu cara. Textbook hanya tunjuk satu cara sajalah. Okay, but can you suggest to me how we would be able to count the W and the P? Kalau textbook dia pakai cara apa? Tension in the string equals to 8 cos 60. So actually, what is the textbook actually using? The resolution of forces. Yeah, you can use the vertical component because this is 60. But basically, dia adalah menggunakan hubungan cos. Remember our friends Sokatua? And dia guna cos 60 because cos is equals to P over T. and the adjacent over the hypotenuse. So cos 60 sama dengan pi per 8. Okay, then kamu boleh cari pi daripada sana lah. Okay, so you will get about 4 newtons. Okay, which, yalah, according to that. And then from there, you can find the value of W. Okay, and yesterday, I think Damir showed us that we can use Pythagoras Theorem to find the value of W. And Elijah proved yesterday that even if you use sine, okay, sine 60 equals to W over 8, you will get the same answer also. So whenever it comes to things like this kind, don't forget all the things that you learn in AdMaths about triangles. Okay, because this is where it all comes to play. And as we proved yesterday, there is actually more than one way to find a certain value. Okay, you have to remember things like Pythagoras Theorem, sine, cos, tangent, even the solution of triangles, which we will come to in a little while. Okay, so this is how we will find the value of, this is W, silap tulis di sini. Okay, ini adalah W. Okay, this is another contoh, and this one I don't think is in your textbook. So let's take a look at this. Okay, so diagram shows 3 forces in equilibrium, 2 cables at 70 degrees to the vertical line. Okay, the weight W is 200 newtons, so this is the weight downwards here. Okay, I want you to draw the triangle wherever you are writing this. You want to write in the textbook, so can. Yeah, draw the triangle first, and then we will compare your answer and my answer. Okay, draw the triangle first. I'll give you 2 minutes to do this. Can you do this? Just draw the triangle first. Okay, can. Okay, let's try. Take a look at your triangle and take a look at the screen. Your triangle over here. So the weight obviously is downwards. That's the easiest. Okay, and everything depends on which is your second force lah. Kalau kamu pergi ke sebelah kiri atau kalau kamu pergi ke sebelah kanan kan, your triangle will be slightly different. But in this example, they will go to the right first. They will use F1. Kalau kamu guna F2 dahulu, totally no problem. Okay, it's totally no problem at all. Okay, but in this example, we're going to use this triangle. Okay, because no matter which side your triangle you draw, as long as you get the angle in the correct place, you won't get the different answer. Okay, your answer will be still the same. Okay, so the 70 degrees must be between the F1 and the straight line down. Okay, now in this situation, you cannot use our friend's Sokatua because there is no 90-degree angle. So bezakan antara contoh ini dengan contoh yang pertama. Contoh pertama, we can use Sokatua because there is a right angle triangle, ada 90 darjah. This case, there is no 90 degrees. So we only have actually one option, which is to use the sine rule or the cos rule. Okay, or actually, if you can even do this. You can figure out the rest of the angles. Okay, if you draw a straight line from the F2 kan, is actually 70 degrees lah. And since these two lines are straight lines that are crossed, so this angle and this angle is the same value. Okay, so then what you will get is, since this is 70, this is 70, this will be 40. Now guys, I just want to mention that not every situation, not every situation, these two angles, okay, are the same. Not every situation. Okay, so be very careful when you're doing this triangle of forces lah. Okay, so from here, we find that we can use the sine rule. Okay, so F1 over sine 70 equals to 200 over sine 40. Okay, to find the value of F1. And so when you calculate, you will get 292.38 newtons. Okay, so penggunaan formula ini, you have already learned this last year during AdMaths. Okay, and that's why we taught you that last year. Okay, in AdMaths, because you needed to use this for your physics this year. Amazing kan kau punya syllabus? Merentas semua ini. You use AdMaths in physics also. Hebat. Okay, and so you can do the same thing with F2. You use sine rule. You can even use cos rule if you want. Okay, kalau kamu sibuk-sibuk guna cos rule pun boleh, tidak ada masalah. Okay, but you will get the answer 292.38 newtons also lah. Okay, since F1 and F2 are the same length. Okay, sorry, I don't know what this is for, but same thing lah. Okay, same situation over here. F over here, the T over here, this is the 30-degree angle, and the weight of the box is 5 newtons. Okay, so since we've done this example before, I'm not going to waste time with the triangle. I'll just show you straight now. Okay, so the 30 degrees will be between T and the weight. Okay, and so you can use cos, which is cos 30 equals to 5. This over here is 5, 5 over T. Adjacent, bersebelahan, over hypotenuse. So kau boleh kira value of T. Okay, you use T and then you get T equals to 5.77 newtons. Okay, then you use tangent. You can use tangent, you can use sine, doesn't matter. Sebab ini adalah 90 darjah. Okay, when you are having 90 degrees, okay, tak payahlah sibuk-sibuk guna hukum sine, hukum cos lah. Okay, it makes life difficult. If there is a 90-degree angle, just use SOHCAHTOA. Okay, but the situation macam contoh tadi kan, when there is no 90-degree angle, then you will have to use sine rule, cos rule. Itulah. Okay, so you find that the value of F is 2.88 newtons. So not that difficult lah. Okay, the difficult part actually is drawing the triangle. Once you have the triangle kan, actually it's not that difficult lah. Alright? Okay, let's take a look at this. Yeah, this is a little bit interesting. I want you to think about this situation and draw the triangle first. So you have 4 newtons pulling here, pulling this particular string. Okay, this string is being pulled by 4 newtons punya weight. And then this string over here is being pulled by 3 newtons punya weight. But the angle between this and this is 90 degrees. Okay, interesting, huh? Notice that the 3 newtons, the string is longer, than the 4 newtons punya string. Okay, this is an interesting problem. Okay, and then W is downwards. Okay, I don't know what is W lah. The only thing I know is that the 3 forces are in equilibrium. Okay, so you know what? I'm going to give you about 10 minutes. You draw the triangle first. This is 90 degree, so it may be a little bit easier, maybe. Right? I'm not really sure. Draw the triangle first, and then see if you can find the value of W. Wait, let me check and see. Sekali ini contoh ada dalam buku teks ni. Oh, tiada. Okay. See if you can find the value of W. I give you 10 minutes to do this, and then after that, I'm going to ask a few people for your answers. Okay, give it a try. Okay, so it's been about 5 minutes. Let me see if you have the triangle correct. Let's look at this. Okay, so magic hands movement, triangle. Okay, okay, and then this. Okay, the only problem is the angle. Where does the angle go? Oh, there's no angle. Sorry, wait. Ooh, okay. Apa ini? 960 degrees. Wow. No. Okay, that's interesting. So the 90 degrees actually is here. Really? Yeah. Okay, let me see. Let me hold on. Oh yeah. Okay lah. Yeah, the 90 degrees is actually here because if this is 90 degrees, right? If let's say I draw a parallel line over here, and like this. Kalau sini 90 degrees kan, sini pun 90 degrees ni kan. Sebab dia ya. Oh, so it's a 90-degree angle. So senanglah guna sine cos tangent saja. Kan? Okay. So can anybody tell? This one no need already. Satu kali kau tengok pun kau tahu sudah. What's the value of W? Anybody?
5 newtons.
Okay, it'll be 5 newtons. The easiest way to calculate this is to use Pythagoras Theorem lah. Okay. Sorry, I don't know what this 960 degrees is doing over here. Maybe the silap type lah. Okay, this is another one. This is inclined plane. So I think this is almost the same problem as the one in example 2. Okay, in your textbook. So same thing, we draw the free body diagram. Okay, all these two are very standard lah. Okay, R is always this direction, and then W is always in a very weird direction because the weight is the actual salient force. Okay, and then there's a friction. Adakah friction? Ada, because it is in equilibrium. Okay, so the weight is 60 newtons. When you draw the triangle of forces, this is what you will get, and the angle over here will be theta. Okay, so this here is 40 degrees. Okay, so this angle over here is 40 degrees. So when you draw, then you can determine the value of R and F. You will have to use, how come this is 90? Oh, okay, yeah, it's 90 degrees plus. Sorry, F and R is 90 degrees, kan? Yeah, so here is 90 degrees. So since this is 90 degrees, you can just use the cos. Cos equals to R over 60. Okay, adjacent over the weight. Okay, and you can get the value of R equals to 45.96. Okay, so this example, and then in order to find the value of F, you use sine 40, or you can also use Pythagoras Theorem. Okay, so this one we actually covered a little bit yesterday. I just want to recap with you lah. Okay, so as I said, the most important skill is not so much the calculation tau. Calculation itu senang itu. You have to make sure that you get the correct triangle. Itu yang sangat penting. Once your triangle is correct, then you can just easily calculate lah. Of course, I hope you guys your calculation is okay because ini semua like admits. Okay, right. Okay, this is a picture hanging in the wall. I think we also talked about this yesterday, kan? Yeah, so the angle is 45 degrees lah. Okay, so this is 45 degrees over here, and the weight is 15 newtons. Okay, so when you draw the triangle of forces, notice the question is always the same. Draw the triangle of forces, draw the triangle of forces, and then calculate the value of T. Okay, so when you draw, this one we covered yesterday, so I don't want to waste too much time here. The 45 degrees will be here. Okay, here and here lah actually. Okay, so since this is 90 degrees, once again, it's a 90 degree. And guys, I want to mention that this is not necessarily 90 degrees tau. Banyak bergantung kepada dua sudut ini. Okay, this angle is 45, this angle is 45, so your remaining is 90, no choice lah. If this was 30 and 30, this wouldn't be 90 degrees. That's logical. Okay, so yeah, don't always assume that a triangle when you draw kan is 90 degrees. Never assume. Make sure you have the correct information. Okay, pastikan maklumat kamu betul dan kamu masukkan ke dalam kamu punya segitiga. And since this is a 90 degree angle, it's easy for us to calculate the value of T lah. Okay, we can either use sine, cos or tangent. So in this case, dia guna hukum sinus. Saya pun tidak tahu kenapa, tapi boleh jugalah. Okay, you get T equals to 10.6 newtons, about the same. Okay. So since we have a little bit more time, let's do a couple of exercises. Because I actually want to finish this subtopic today, and then Friday we can start a new subtopic lah. Okay, so take a look at this question, and then I will call somebody to give me the answer lah. Okay, the forces are in equilibrium in all the phenomena below, except which situation?
C.
Okay. A mango falling from a tree are not in equilibrium because something that's falling from a tree will have an acceleration. Okay, thank you. All right. Number 2, which diagram shows forces in equilibrium? Okay, it's situation A, situation B, situation C, situation D. Okay, which one is it? Damir. Yeah, okay, so it's A. A is equilibrium. Everything else, there is a resultant force. Okay, dia punya resultant force bukan sifar. So this situation ada acceleration, ada acceleration, ada acceleration. This one no acceleration. Okay, so when there's no acceleration, then the forces are in equilibrium. Okay, good. Okay, question number 1, number 2, and then number 5. Okay, so diagram 5.1 shows two boys pushing a large box. After some time, the box remains stationary. Tak bergerak lah. Diagram 5.2 shows an aircraft moving forward with a uniform velocity at a constant height. Okay. Everybody, when you see the words uniform velocity, I don't know how many times I must mention this. Okay, what does uniform velocity mean? Sikit lagi saya mau panggil Umar, kan, tapi Umar tidak wujud sudah di sini. Sorry, who am I going to call? What does uniform velocity mean? Rania.
Yeah, sorry, my mic lagging tadi. It means it has zero acceleration.
Okay, very good. Okay, and what does, sorry, another person, what does zero acceleration mean in terms of the forces? Luis? Uniform velocity means zero acceleration. In terms of forces, what does zero acceleration mean? Luis?
It means the forces are in equilibrium.
Okay, very good. Okay, boleh sudah ni. You can all become physicists. Okay, it means the forces are in equilibrium. Okay, all right. So, based on the situation, state the similarities about this one, the magnitudes and the direction. So, F1 and F2 will be equal. But what about the directions? Are the directions same or different? This one is like a soalan cepuk emas lah, tapi quite easy lah. Okay, so the directions will be opposite directions lah, obviously lah kan, they can't be the same direction, because if they're same direction, then the forces won't be equal. Okay, by the way guys, ini adalah contoh soalan SPM. Senang kan? Dia suruh kamu begini saja. That's why this is not difficult. Question senang ini. Okay, what is the net force in both situations? Okay, what is the net force in both situations? Michelle.
Zero.
Okay, very good. The net force is zero in both situations. Because, as I said before, this requires us to really understand the situation. When everything is in equilibrium, when the forces are in equilibrium, whether it's moving or it's stationary, okay, the net force will always be zero. Net force juga dikenali sebagai resultant force lah. Okay, net force is macam bahasa lama bah. Okay, but now we use the word resultant force. Okay, so based on the answers in 5A1 and 5A2, what is the physics concept that is involved in this situation? Okay, the physics concept will be forces in oh no, my goodness, equilibrium. Okay, sorry, there's a spelling mistake here. Bukan equilibrium, equilibrium. Okay, equilibrium. Okay, so another aircraft has F3 greater than F4. Describe the motion. Okay, now, so you have this situation over here where the F3 is bigger than F4 now. Okay, can anybody tell me how does the motion, can anybody describe the motion of this object to me? Wilson?
The aeroplane will move to left.
Okay, will move to the left. How? Sorry, maybe my question not so clear. I want to try to up your answer lah. So it's correct. Okay, the airplane is obviously going towards the direction of F3 lah, which is to the left. Okay, but you also need to mention how is it moving. Is it moving with a uniform velocity, with a, yeah. Can I take a guess, Wilson?
Acceleration.
Okay, it will move with an acceleration. Okay, alamak, macam ni saja dia punya jawapan. Okay, fine, it will move in an acceleration. Okay, and the explanation for this answer is because there is a resultant force. Okay, so because there is a resultant force, there will always be acceleration. When there is no resultant force, oh my lord, I've said this so many times in these past few weeks, I feel like a broken record. Okay, when there's no resultant force, means it's uniform velocity, yada, 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 yada. Okay, question C, diagram 11.2, page 31. Sorry, forget the page. Okay, shows 4 flagpoles, different specifications, begini. So the maximum tension of the string over here is 1000, but this maximum tension of the string is 2000. Okay, density of the pole P is 1500, density of the pole Q is 900. The flexibility of the pole is low, so this is not very flexible. Sorry, do you guys know what's the meaning of flexible? Like if you want to have a tiang kan, is it better to have a flexible tiang or non-flexible tiang? Yeah, so Wilson's fingers are very flexible. Like you can see Wilson's fingers, yes, very flexible. I'm so jealous. I can only do this because mine is pianist finger lah, so I can't do the the jelly that you're doing. Okay, so yeah, anyway, you have to think about this. I think this is there are two other types, sorry. Okay, so this one tension 1000 beginilah. Oh, this is mesti buat pilihan ini kan. Yeah. Okay, so let's talk about this. Let's talk about the density, the flexibility, the maximum tension, and the height of the strings. Okay, so let's talk about density. Do we want a density first? Okay, let's talk about the density. Do we want a high density or low density pole? And tell me why. Okay, Wilson. After Wilson, I will always call Wilson. Wilson, what do you think? You want high density or low density pole?
High, I think.
High density, yeah. Why high density, yeah?
Don't know.
Don't know. Okay, wait, sorry, I forgot to mention. So we are going to explore this, and we want to say, we want to find a flagpole that can withstand the strong wind. Okay, so this is our main purpose of choosing the flagpole. Which flagpole is the most suitable? Okay, so Wilson's answer, he said, is high. We want high density, but he cannot really give a reason why. Does anybody have a different answer, or should we just follow Wilson's answer? What do you think? Anybody? Anybody want to give opinion? High density or low density flagpole? Which one better?
I'm not sure I understood that.
Oh, Elijah also say high density. How? Okay, so actually I also don't know. Oh, okay, so they cakap di sini low density. Oh no, I've given all the answers, bodoh. Okay, so actually usually we want to choose low density lah. Okay, we choose low density because when things are low density, density especially, sorry, bukan ini, high. Sorry, salah ni. Low density. We want to choose low density because things that have low density are usually lighter. Dia lebih ringan. Okay, and we want that, because do you know how heavy a flagpole is? Okay, it's very heavy, and if you can make the pole lighter, it's better lah. Okay, so we choose low density because it is lighter. Okay, so while I think there is actually kan, kalau saya fikir sebab ini kita mau flagpole yang bertahan angin yang kuat bahkan. Actually, I also was tempted. Saya pun macam, ya bagus juga high density kan, so dia lebih berat. Okay, sorry, dia heavier lah kan. So if the mass is bigger, maybe dia boleh tahan angin yang kuat. But I realized that actually density dia lebih kepada dia senang mau angkat, senang mau kasih berdiri, begitu bah. Doesn't really have that much to do with whether dia boleh tahan angin atau tidak lah. Okay, so yeah, don't you think it's true? Say for example, let's say me and Jing Wen lah. Okay, let's say me and Tian if we both stand in the strong wind, right? Both of us also can still bertahan. No man? Do you think that Tian will fly off first just because she's lighter? No, I don't think so. I think we will all both still be able to tahan lah, even though I'm heavier and Jing Wen is lighter lah. Okay, so density is smaller because we want the flagpole to be lighter. Okay, how about the flexibility? Do we want the flexibility of the, is it flexibility? Flexibility. Do we want a low flexibility or high flexibility? What do you think? Jing Wan lah, since I called your name so many times already.
High.
High flexibility. Why?
So it can move like more flexible.
Okay, so now I realize okay, so yeah, the answer is high lah. I think that it will be better to choose a high flexibility, because if something is not very flexible because angin kuat kan akan memaksa dia untuk berlentur bah. It's going to force the flagpole to so if the thing is not very flexible, dia akan mudah patah. Things that are not flexible usually break faster. Don't you think so? Kan? Benda yang not very flexible kan dia akan lebih cepat patah. Just like humans lah kan, kalau kita tidak fleksibel, wow, moral lesson. Okay, if we are not flexible lah, okay, kita yang akan men-stress diri sendiri. So I'm actually very thankful that you guys are flexible enough to allow me to postpone the class by 1 hour lah. Okay, tapi saya kesian lah. Sorry to the people that are taking tuition at 8 o'clock lah. So okay, so yeah. So flexibility usually dia kaitan dengan patah lah. Okay, something that is not very flexible is good for certain situations. Contohnya kamu mau lukis graf garis lurus bahkan. You don't want a flexible ruler if you want to lukis graf garis lurus. Kan? Because kamu takut dia terlampau fleksibel kan, terus kau graf garis lurus nampak macam jari jemari si Wilson. Okay, so we don't want that lah. But anyway, in this case, we want a high flexibility lah. Okay. Third one, the maximum tension. Should we have a high maximum tension, 2000 newtons, or low maximum tension, 1000 newtons? What do you think? Let's ask Lester lah. Lester, what do you think? High maximum tension or low maximum tension?
High,
Why? Why high maximum tension?
so the string doesn't snap when there is strong wind.
Okay, that's a very interesting concept. High maximum tension so that the string doesn't snap when there is strong wind, because the tension is very high. Do you see where I'm getting at? The tension very high, then not easy to snap. Tension. You guys are form 5. You are going to realize what is the real meaning of tension. If your tension is very high, do you think you will snap easily or more difficult to snap? What do you think? Everybody's like, apa tu tension tu? Saya punya kehidupan senang saja. Nah, Elijah says easy to snap because the tension is high. Interesting, huh? I would say that I would want a low tension. Okay, because so when you put a flagpole, even kemah pun begitu tau. You don't want to put it too tension. Like guitar string lah, Elijah plays the guitar here kan. If your guitar string is too tense, means dia sangat ketat macam ni tau. Okay, like kau petik sikit pun dia putus sudah. It's too much tension. Okay, you want to find the perfect balance between the tension and also the sound lah when you play guitar. If the string is too tense kan, kamu sentuh sikit terus dia patah sudah. And just like humans lah, not good. If we are too tense, kalau kita setiap malam kita ada tuition accounts jam 8 sampai jam 11 kan, kamu pun akan menjadi sangat tension. And then one day you're just going to throw your calculator in somebody's face and like, saya tidak mau ambil account sudah. Okay, so I think that low tension is better because the low tension and the flexibility go together, if you ask me lah. Okay, but we can look at the answer later lah. I think it's low tension. Okay, but I think it's interesting that Lester pointed out that maybe high tension is better. Okay, I don't know. We'll take a look at the answers in a little while. I may be wrong. Okay. Okay. Lastly, height of the strings. Do we want a low height or high height? Oh, so interesting. Low height or high height? Oh, interesting. What do you think? Let's ask Mozac. If you're going to tie a flagpole kan, kamu mau dia punya tali tinggi di atas begini kah atau rendah saja?
High.
More? Sorry, high. Lower.
High.
High. Why high? Yeah, so
More stable.
more stable. Sorry, is that what you said?
Yes.
More stable,
I think
okay. I'm not sure if you remember your science form 2. Stability ada kaitan dengan ketinggian bahkan. Kan? The higher your center of gravity, your stability macam mana? Lower or bigger? Lower bahkan. So the taller you are, the less stable you are lah. So people like Valerisa are very stable one because they're short lah. Okay, so people like me, like Wilson, like Elijah, kami yang gergasi ni kan, kami sangat tidak stabil lah, because our center of gravity is higher. Okay, but now Mordecai is saying we put the string high so that it's more stable. Tapi the string high means lower center of gravity. Itu saya mau cari gaduh saja by ini sebenarnya. Okay, saya bukan cakap yang saya betul. I don't know what's the real answer yet. Okay lah, actually I do know lah, tapi saya sengaja mau cari gaduh lah. Okay, I think that maybe, you know, maybe after our class today, kan, you should go and find a flagpole lah, and then because it's windy today. Do you realize it's so windy outside? I don't know about your place, but my place here is so windy. My door banyak kali sudah slam. Maybe you should go and try to tie something with a high string and a low string, see which one is more stable. Yeah. Actually, I'm not sure. I feel that maybe Mordecai's answer seems to make sense, kan? Kalau kita ikat tali tinggi-tinggi, kan, dia akan lebih stabil lah. Kan? Don't you think so? Anyway, okay, let's take a look at the answer. Banyak soal from my mail. Okay, so the density is low because it's light. High flexibility so that it will be difficult to break. Okay, we want it to be flexible. Can sway easily without breaking. We want the dia tidak bagi tahu pula di sini. Okay, so we want the high position of the string lah. Okay, so actually Mordecai's answer is correct. Okay, high position of the string so that it is more stable. Notice that the area that they cover is the same now, is 1 meter. Okay, the area that they cover is the same, is 1 meter. But when you put the string on the high over here, okay, then it will be more stable. Okay, because dia sebenarnya not really so much kaitan dengan center of gravity lah. Okay, saya hanya mencari gaduh saja sebenarnya. It is not really anything to do with center of gravity. It's just more stable if you put it higher because there's more ground to cover here lah. Okay, if you want to talk about in terms of center of gravity, kalau kita letak low, bahkan sini jarak yang besar, and since this jarak is very besar, kan, the center of gravity is, you know, much higher, so dia low stability. Kalau kita ikat di sini, dia punya gravity yang dia kena overcome kan ini saja. So the center of gravity ini kan, bahagian ini adalah low. Okay, so that's why it's more stable. Okay, kita selalu fikir center of gravity is dari sini sampai ke bawah, bahkan actually it's not. Okay, sometimes it can be, you know, how much dia memegang lah. Okay, so sorry, it's supposed to be the maximum tension is supposed to be high lah. Okay, yeah, the maximum tension is supposed to be high so that it does not break easily. Okay, but it cannot be too high lah. Okay, it cannot be too high, otherwise it will break easily. So this is actually not to say a trick question lah. Dia macam memerlukan kita untuk memikir sedikit lah. Okay, whether we want high maximum tension or not too high maximum tension. Okay, so the best flagpole is flagpole Q because it has low density, high flexibility, high tension, and high position.